Hi, good morning everyone. Let's get started with the next topic for this training, which is on SAP's memory management. Okay, so basically the memory management, you can see users need two kinds of memory. One is the R3 buffers. Basically this is the place where all the programs, the tables and field definitions, customizing tables are stored. Then user context. Basically this is the memory attached to individual users for variables, lists, internal tables, administration data. Okay, now the physical and the virtual memory. So basically you can see that this is a server, and this server has the physical memory, and we are utilizing the paging file space, that is the operating system's paging file, which normally we call it as a swap space also. And so this particular virtual memory, it is consisting of you can see it's a combination of a physical memory and a paging space. Maximum virtual memory is less than or equal to the physical memory plus operating system swap space. Okay, so this is about at the OS level. Next is R3 memory, basically the local memory for work processes. Here you can see the local memory is basically you can see is allocated to the work processes, different work processes. You have a number of work processes. Okay, so local memory is for the executables, for the data, for the stack, for the buffer for database transfer, local role area, local paging area. Now, second thing is about the R3 buffers. Okay, in the shared memory you have the buffers, and shared memory is associated with all the processes of one instance, that is the local memory. R3 buffers contain global objects for all users and work processes such as programs, customizing tables. Okay, so we just saw the work process, the buffers, and the extended memory. Extended memory contains user context, that is objects associated with individual users such as variables, lists, internal tables. Okay, then heap memory. You can see that this is the heap memory, which is the temporary memory. Contains the user context. For example, when extended memory is full, okay, is allocated and released on demand. Okay, so we just saw the different types of memories in the system. Okay, now it's the role memory. Role memory contains the initial part of user's context. Okay, then the paging memory. You can see that the paging memory is at the OS level. Paging memory contains ABAP objects such as extracts, context independent objects such as exports. So from the system point of view, what we have covered so far is we have covered R3 role file, R3 paging file, that is the paging buffer, the role buffer, the buffers for programs tables, extended memory, that is the user context, heap memory, and the different work processes. So let's get into the memory allocation concept. A work process is dedicated to a front-end user only when a specific dialog step is being processed by the application server. A user can be dispatched to one work process in one dialog step and to another work process in the following dialog step. Over the course of time, users are dispatched to different work processes. In the course of their work, okay, so you can see that for one activity the user is allocated to one work process, another activity he could be allocated to the other work process. So in the course of time the user in dialog processes, user accumulates various pieces of data such as pointers to programs they are using. The accumulated data is used called the user context. A user context enables, for example, the material number you are working on to recommend by the system and proposed as the default in a following transaction. So just take note of this key concept is basically whenever a user connects, he will be allocated a user context. So that is very important. And user context is basically its user's authentication information, the roles which is associated with the users. Okay, basically the information associated with the objects of users. Okay, then rollout. So rollout is basically once the user session is closed, it needs to be rolled out. So that is called a rollout. So the mechanism known as rollout ensures that when user 2 needs to use the work process which has just been used by user 1, the user context data of user 1 is not be lost or overwritten. Okay, next is the rollout saves the user context data for the dialog user when he or she exits the work process. Okay, now let's get into the work process. Work process, basically here you can see this is work process 1, work process 2. Work process 1 is occupied by another user when user 1 was formerly working in process 1, is therefore dispatched to work process 2. The user context data is copied into work process 2 by the mechanism known as roll-in. So roll-in is like whenever the user connects to a work process, his context is copied. Okay, so that is the roll-in. So his context is copied into that particular work process. So user 1 can then continues from where he or she stopped in the earlier work process. Okay, now the role area and the paging area. Okay, role area basically the user context objects such as authorization, set or get parameters, internal tables, report lists, and in paging area especially memory for specific ABAP commands. Okay, the paging area which stores the application program data that corresponds to specific ABAP programs including extract, import to memory, export from memory, and call transaction. The size of these areas is configurable using R3 profile parameters. Okay, now role buffer and paging buffer. Okay, here you can see when there is a buffer space available, the role area and the paging area are held in the respective buffers in the application server. So when there is not sufficient buffer space, the role area and the paging area must be stored in the respective physical disk file, for example, role file and paging file. Okay, so that is the underlying principle, that if you have it available in the memory, use it from the memory, else it is provided from the file using, say, role file or paging file. Thus the user data processing in work process is stored in two areas, the role file and its associated buffer, page file and its associated buffer. Okay, next is the extended memory. User buffers, user contexts are not only stored in role files and the corresponding buffers, they are primarily stored in R3 extended memory. So in R3 extended memory, a large area of memory shared by all available work processes can be accessed through pointers using extended memory as well as role files, thus reduces the amount of copying from role area that is required during user context switches and avoids the overhead caused by large roll-in or rollout. And if you see there is a lot of rollout, roll-in, a lot of swapping or paging taking place, that means your system is running short of memory and you need to feed in with more memory. Okay, R3 memory allocation. Allocation sequence for dialog work processes. So first thing is a defined initial period of the role area is used. To keep the usage of the role area to a minimum and make more use of extended memory, only a small portion of the role area is used initially. The size of this area is set by this parameter, that is, this is the parameter, that is ZTTA / role underscore first. So note, the independent of parameter, this therefore is a minimum amount of role area that is always used. For example, you can set this value to 1. Not just 1 byte is allocated, but the minimum amount required for administration data. Okay, so we will be getting into the system to see these particular parameters. Okay, now the allocation sequence for dialog work processes. Extended memory enables the data to be stored in your system where it is efficiently accessed by pointers rather than by a copy process. The extended memory per user may vary from 1 MB to 100 MB. Okay, now here you can see the sequence. So the first thing is role memory up to say this parameter, extended memory using this parameter, role memory remainder of role area, and heap memory up to this particular value. Okay, now the next thing is R3 memory allocation for non-dialog work process. So allocation sequence for non-dialog work processes on NT and dialog work processes on all platforms. So this is the sequence basically. Okay, allocation sequence for non-dialog work process on all platform except NT. So this is the sequence. Okay, now the next thing is the memory allocation. Basically here you can see that the first work process, which has the role area, the paging area. Second work process, it has the role area, the paging area, and heap memory. Heap memory is released after the use. Then you have the extended memory, and this is the swap. Next thing is releasing the heap memory. Okay, so here you can see that this heap memory is released after its use. So when the limit set in abap/heap limit is reached, the work process is flagged for automatic restart. Okay, you can see this parameter, that is abap/heap limit. Now let's get into the memory management parameters. So these are the memory management parameters. Okay, so you can see role underscore first, role underscore area, role underscore SHM. Okay, then we have role underscore max FS. Okay, so these are basically the memory management parameters. So let's get into the system to see these parameters. So let me connect to one of the SAP system to show you guys how these parameters look like in an SAP system. Okay, so let me connect. Give me a second. Okay, so I am connecting to a SAP system and I wanted to show you guys how the memory parameters looks like and where do we store these memory parameters. Okay, so I am connecting to a system called Solution Manager. Basically this system is used for managing the different systems within the landscape, and this system has become even more critical, especially from the basis point of view, because this is the central system, and at this central system you can connect to the different systems. So that is the key benefit of connecting to this particular system. Okay, so give me a second, let me connect to the system. Okay, now we are connected to the system. So let me go to this transaction and let's select one of the profile. Okay, so I have selected this profile. Let me go to the extended memory and say display. Okay, in this particular tab, what we are interested in the memory specific parameters, say role specific parameters. So I will just type role and it will give me all the parameters specific to role. Okay, so this doesn't show any of the role related parameters. Okay, so there is another way to get into these parameters is, let's go to the RZ11. Okay, so RZ11 command will tell you that what all the role related parameters which is available in the system. Okay, here you can see that these are the role specific parameter. Role first. Okay, you have role area, you have extension, dialog and non-dialog. Say if I want to see the existing value of this and what this stand for, I'll just click on this, and here you can see that short description. This is basically the first used part of memory at ZTTA_role. Okay, so that is about this particular parameter, and its current value, you can see what is the current value. So it is set to minimum value is this, maximum is this. Okay, and in case if the value is changed, it will tell you that what is the current value. Okay, so that is about this particular parameter, and if you want to see any other parameter, you can just go to that parameter and it will tell you that, okay, what is this parameter, what is the minimum value, what is the maximum value, and what is the current value. Here you can see the difference between this value and this value. So these are the customized values depending on the environment that you are in. Okay, so that is about these values. Okay, so let's continue with our presentation. Okay, so we have seen this heap limit. Okay, let's see what is the value of this heap limit. We have not yet seen this. Okay, so let's type this particular value, say heap limit. Okay, so you can see this is the name of the parameter. This is a short description. It is telling that if this limit is reached, work process will be killed at next chance. Okay, then this is the minimum value and the maximum value, and this is the current value. Okay, so let's continue. Okay, we have seen the heap limit. Okay, now the memory management parameters we just saw. These are the different parameters which are available. You can see the current value. Okay, so let's go to the next slide where it is showing the work process. Basically, if we go to the transaction called SM50, okay, let me take you to this particular transaction SM50. Okay, what this transaction is, basically SM50 shows the different processes which is there in the system. Okay, if I type SM50, here you can see this is the list of the different different processes which is available. DIA stand for the dialog work process. You can see these are the different dialog work processes. Then you have one update process, you have one enqueue process, you have background process. These are the different background process which is available. Then we have the spool, we have the update 2, basically it's V1 and V2 updates. Okay, you can see the existing status. Okay, reason, then whether it is started or not, is there any error or not. Okay, then we have the semaphore numbers, CPU, time, report. Okay, basically this is giving the details of different process related parameters. Okay, so in case if suppose I want to kill a particular process, I just select that particular process and say kill, that is process, cancel with core or without core, restart after error, yes or no. Basically in case if I want to trace it, I can trace it from here. Okay, so that is about the different parameters and this particular SM50 screen. So just take a note of this screen. Basically this screen you may be seeing when the system is running out of memory. Basically here this is R3 heap memory. Okay, so it's getting exceeded, so the system is getting into the private mode. Okay, now ST03 transaction, basically it's the analysis roadmap. Okay, so let's get into the next one. Is here you can see insufficient extended memory. Okay, the parameter setting for role memory and extended memory allocate only a small amount of memory and thus forces the work process to allocate heap memory too soon. Okay, sufficient extended memory. You have implementing R3 extended memory. So basically just take note of these parameters and the note number where you can find more details about this zero administration memory management. Okay, then let's get into the Unix side. Okay, in Unix you can see you have local work process. These are the R3 buffers. You have role memory, extended memory, heap memory. So basically this is the user context. Okay, so whenever any user logs in, so this is the context which is allocated and its initial size in MB and heap area for diag or non-diag. So the summation of this is what is the user context. Okay, that's all I wanted to cover. Thanks for joining and have a nice day. Bye-bye.